So I've been working on AI image generation for some time now, and well, should I say playing around with it. And this is one of the results I got. So I have multiple work. This is Comfy UI. I'm using Comfy UI. I was using the desktop application, but it was giving me a few issues. So I switched to the GitHub installation. So I just installed it directly from GitHub. That's how you notice I'm running it in my browser, right? Like I'm accessing it from my browser. There's no desktop application this time. So I have multiple workflow files here. I have one for Anima, I have one for Z image, I have one for Anisee. This one I'm not even going to be using anymore because it's not worth it. Let me just put it that way. So this is my workflow file for Z image. You'll notice I'm using Z image turbo, BF16, Gwen 34B, and then AE safe tensor for the VI, right? I know some of the things I just mentioned might go a little bit over your head if you don't really know about these things. But basically, this is the diffusion model, the one that generates the image. This is the clip model or the text encoder. So this is what encodes the text for the image generation. The VI, come to think of it, I actually don't know what the VI does. I think the VI is responsible for encoding and decoding the image. But I'll have to check on that. So yeah, this is just the workflow. So you notice there's a positive prompt and a negative prompt. And then model sampling, seed control. Seed control. This is an anti-latent image. So it just specifies the dimensions, and then we have the generate image node. So how many steps? 8. So for the turbo, the Z image turbo, right? It can use 8 steps and it's good. For the Z image base, I have the Z image base as well. The Z image base is this one, right? Z image BF16. That one requires a minimum of 28 steps for good results. And 28 steps, like you're basically just multiplying the amount of time it takes per iteration by 28. So this one, it takes about, I actually don't know how long. Oh, I think I have the terminal output here. Yeah, it takes about 49 seconds per iteration, right? So multiply that by 28 steps if we are using the base image. So here we're using the turbo image, the base model. Here we're using the turbo model, so we can use 8 steps. And we have these. So the denoise, I'll talk about the denoise later. Let me just show you my results so far. So this is Anima's original, just like the normal Anima workflow. And then I have Anima upscaled. So you'll notice that for the Anima upscaled, there isn't much of a difference between the original and the upscaled. Just like maybe a little bit more details, but that's mainly because the upscaling, I only upscaled it by a factor of 1.25. Usually the higher your upscale factor, the better the more detail will be added into the final image. So I took this image, this original image, and then I upscaled it by a factor of 1.25, and this is the result. And I'm trying to work within the limits of my machine's resources, my machine's capacity. So yeah, the upscale is basically not even necessary because it's almost similar to the original, right? Now I want to show you the difference between Anima and Anisee. Anima and Anisee are both anime specific models. So this is the Anisee generation. You'll notice that the Anisee generation seems to have just a little bit more detail. Like if you look at the shades right here, it looks a little bit more detailed than this version, but they are both basically comparable. They are both basically the same. It's the same prompt, right? So yeah, you notice that the pose is the same, the hair color, the eye color, everything is the same, right? But yeah, they are basically similar. So I don't really have a preference in whether I prefer Anima or Anisee. I guess I'll just keep testing them and see which one I like better. But anyway, now I want to talk about okay, so let me actually show you Z image's results. When I tried Z image, so you'll notice this one. I think to me this is the best one so far, and it's because this is the base image, the base model, the Z image base model. So it took 28 steps to complete this generation, and this is the normal Z image, the Z image turbo, which took 8 steps, right? So you notice that this one has a little bit more color, it's more vibrant, it's a little bit more um, it's just a little bit better than the turbo generation, right? But the only problem is these I don't know why the trees are that's supposed to be a classroom. I don't know why the branches of the trees are in the classroom. This doesn't make sense, but I guess that's what you get with image generation. AI image generation anyway. But yeah, I prefer this version to the turbo version, but the difference is not so bad that I would need to use the base version. So right now I am resorting to using the turbo version because the turbo version is faster. I can't use the base. I can use the base version, but it will be overkill. So, and another thing, you'll notice since the Anima and Anisee are optimized for anime, you'll notice this one, the coloration and everything is better suited for an anime aesthetic. This one doesn't really follow the normal anime aesthetic, but there are some animes that still look like this, so it's not really much of an issue. Okay, now I want to talk about character reference, using character references. So like I said, this denoise value, it basically tells the workflow or the model to, it gives the model room to make changes. So the higher the value, the more changes you see, the lower the value, the less changes you see. So if you want, you can, instead of using an empty latent, so this node is called an empty latent image node. Empty, this one, empty latent image. You notice width, height, batch size, and it's the same thing here, right? Width, height, batch size. Yeah. Let me get rid of this. So you could use instead of using the empty latent image, you can use an actual image node. So node image. You can use an actual image node, and I think the image, so you select your image and then the image will go into, I think it's a vi encode. Wrong place. Vi encode right here. Yeah, exactly. So the image goes into pixels and then you bring in your vi. So this is my vi over here. You'll notice I connected it here. So I can just bring it down here. And then I can send the latent to the generate image node, which is here. So what that will do is it will take the image, it will use the image as a reference in the generation that is going to handle. So this what I'm going to show you right now is basically my testing. So when I tested with the denoise, so the denoise value, like I said, when you set the denoise value, if you have an image reference and you set the denoise value, the higher the denoise value, the less likely it will be that the final image will follow the original character reference. The lower the value, the higher the likelihood that the final output will follow the image generation, the character reference. So let me just show you what that means practically. So this is the original image, right? And then with this one, I use the denoise value of 0.4. You notice it's basically just a photocopy, even though the prompt I used was different. So the prompt I used was basically, it's the same person, but then playing tennis, right? Or the tennis court playing tennis, about to hit a ball. And you notice the tennis ball is there, but due to the fact that the denoise value was so low, it's just photocopied the original image, basically. When I increased the denoise value to 0.7, you notice it was a bit better. So over here, right? It was a bit better, but then it still maintained the same pose and everything. But yeah, it's a little bit better. So when I changed it to 0.9, you notice finally it is actually getting closer to what the final thing should look like, which is the person playing tennis about to hit the ball on the tennis court, right? It doesn't have the same pose, but it's still close to the original character design. Now, when I use a denoise value of 1, this is the strongest, right? And what that basically did was it just got rid of the original character reference completely. So you notice the person doesn't even look the same anymore. Even the hair color is different. This is more of a blue tinted hair than the original silver colored hair, right? So yeah, those are the various knobs and dials that go into this sort of thing. So let me see. I think the next thing is I want to show is this. This is actually one of my favorite images generated so far, right? It's supposed to be Bugs Bunny style, but then not Bugs Bunny exactly. So yeah, the bunny, red headband, red jacket or whatever that's supposed to be, and then the tortoise, right? Yeah, so you notice these are the logs. I'm currently testing out a specific pipeline, and these are the logs, right? So it takes me about where is it? It's about, oh yeah, that's it, about 450 seconds per one image generation using the image table. Yeah, so that's my experience using Comfy UI and generating images with Z image, Anisee, and Anima so far. I'll be using Z image for general purpose things. For example, this one right here. I'll be using it for stuff like this, and I'll be using either Anima or Anisee for anime specific generations. I might mess around with a few other models. Look at this one. Just look at this. She's holding two tennis rackets. The hand is all weird, and then she's hitting the ball. Like, this just doesn't make any sense, right? Anyway, yeah, I'll be using. I might test out some other models just to see how that goes. But yeah, this is my experience so far. I think out of the tennis image generation trials, this is the best one that came out. But even this one, look at the hand. That is not an anatomically correct hand. Let me see. Is that the best one? Maybe the animal one might actually even be the best one. This one is kind of cool. This one is kind of cool. Just I didn't follow the original character design. Yeah, I think this might be the best one, followed by this one. No, whoops, not that one, this one. Yeah, followed by this one. Yeah, personally I prefer this one over this one. Yeah, cool. So that's it. You can try and guess what exactly I'm going to be using all this for, but I doubt you'll be able to guess. But hey, feel free to try. Alright, thanks for watching and see you in the next one.